Children, welcome back to our chemistry class. Last class, what we study? When a substance is heated, it can cause interconversion of states of matter, thermal expansion of substance, chemical change. Last class, we studied interconversion of states of matter. Today, we are going to study thermal expansion of substance and chemical change. How we can prove that solid, liquid, gas expands on heating?
Look at the thermometer reading how it increases when it comes in contact with a hot substance. This is due to the expansion of mercury when heated. Let us take a metallic ball as shown and a metal ring through which the ball can just pass at room temperature. Now heat the metal ball over a flame for a few minutes. You will be surprised to see that after heating the ball, it does not pass through the ring. The ball size increases. Now, allow the ball to cool down to room temperature. If we again try to pass the ball, it easily passes at room temperature. This means the metallic ball on heating, its size increases, so it does not pass through the ring. This increase of size of the solid on heating is called expansion. So, we can conclude that solids expand on heating.
Next, we can check is liquid expands on heating.
Take a round bottomed flask as shown here. Let's fill with colored water up to its neck. Insert a long capillary tube in single-holed rubber cork and fit it to the neck of the round-bottomed flask. Place the entire apparatus on a tripod for heating. Mark the positions of the water level in the capillary, say P1. Now heat the round-bottomed flask for a few minutes. You will observe that initially, the water level decreases, say P2, and on further heating, the water level increases, say P3.
This shows that liquid expands on heating. Next, to show the thermal expansion of a gas,
we need a long capillary tube CT as shown and trap a few drops of colored water A in between the capillary tube. Insert the capillary tube in a single hole rubber cork C and fit it to the empty, that is air filled round bottomed flask F as shown. The gap between the cork and the flask may be sealed by using wax. The apparatus is fixed on a stand S as shown. Now warm the round bottomed flask with a spirit lamp H as shown. Look how the colored liquid moves upward B on heating and moves downward, that is A, on cooling. This is due to the expansion of the air G inside the round bottom flask on heating. On heating, the expanded air of the flask pushes the trapped liquid up in the capillary tube, and similarly on cooling it contracts. The atmospheric pressure pushes the colored liquid down in the capillary. So, gases expand on heating.
Next, chemical change. Chemical change on heating. We can discuss some examples. When a piece of paper is burned, a new substance ash is produced. Even when the burning is stopped, the ash cannot be changed back into a paper. This shows that the formation of ash from the paper is a permanent and irreversible change. That is, the ash again returned back to paper? No. That is, the ash is a new substance. It is a permanent change and it is irreversible change. So the change is permanent and irreversible in the case of chemical change. Chemical change and their characteristics. First characteristics of chemical change, new substance are formed. Second one, the change is permanent and irreversible. Third one, there is a change in mass of original substance. Fourth one is exchange of energy takes place. What are the characteristics of chemical change? First one, new substances are formed. Second one, this chemical change is permanent and irreversible. And chemical change here, change in the mass of original substance and exchange of energy takes place. Okay. Next is burning of candle, physical or chemical change. How we can prove that? When a candle is lighted, some of the solid wax first melts and turned into liquid wax. Then it burns to produce a flame. A new substance, carbon dioxide, water vapor are formed along with the evolution of light and heat energy. This shows a chemical change. When a candle is lighted, it burns to produce flame. Okay, so some smokes are produced from that candle. That is the new substances, carbon dioxide and water vapor. And heat energy and light energy also produced from that candle. This shows a chemical change. Is it clear?